Hello everyone, and welcome back to the Fluctus Channel. Landing a massive aircraft in the U.S. Navy aircraft carrier is demanding, because the runway is not a runway at all. It is a steel deck moving through wind, waves, engine exhaust, and flight operations. For decades, a trusted aircraft for that trip was the C-2 Greyhound, the Navy's carrier onboard delivery aircraft. Built by Grumman from the same family that produced the E-2 Hawkeye, the C-2A was designed to carry people, mail, parts, and urgent cargo between shore bases and aircraft carriers at sea. The Greyhound is not a sleek fighter. It is a high-wing, twin-engine turboprop transport with a large rear cargo ramp, folding wings, and a reinforced landing gear built for carrier impact. The aircraft can carry roughly 26 passengers or about 10,000 pounds of cargo, making it a carrier lifeline. When a ship needs an aircraft part, medical movement, fresh mail, special equipment, or personnel transfer, the C-2 becomes the fastest bridge between land and the floating city offshore. A carrier can remain at sea for months, but it still depends on steady delivery from aircraft like this. A C-2 mission begins long before the aircraft touches the deck. Cargo is weighed, tied down, and balanced so the aircraft remains stable during launch and landing. Passengers board in protective gear, and the crew checks communication, fuel, navigation, weather, and carrier recovery instructions. As the aircraft approaches the ship, the pilot lines up with a landing area that is angled across the carrier deck. The ship turns into the wind to create airflow over the deck, while the landing signal team and flight controllers help guide the approach. The final seconds are violent and precise. The pilot lowers the landing gear, sets flaps, keeps power steady, and aims for the arresting wires stretched across the deck. The aircraft descends toward a runway that may be pitching and rolling with the sea. Unlike a normal runway landing, the pilot does not flare gently and float. The Greyhound must arrive firmly, catch a wire with its tailhook, and stop in a short distance. The hook grabs the cable, the arresting gear absorbs the energy, and the aircraft is pulled from flying speed to a full stop in seconds. After landing, deck crews move quickly. They signal the aircraft forward, fold wings when required, chalk wheels, unload cargo, remove passengers, and prepare the deck for the next recovery or launch. Every movement is choreographed because jet blast, spinning propellers, tow tractors, tie-down chains, and other aircraft crowd the flight deck. The C-2A's final years gave the aircraft a farewell tone. As the Navy moved toward the CMV-22B Osprey for future carrier delivery missions, the Greyhound continued making last runs, final carrier landings, and farewell takeoffs. Its long career proved that carrier aviation depends not only on fighters and attack aircraft, but also on humble transports carrying the parts, people, and supplies that keep the entire force alive at sea. Arrested landing is the reason a carrier can recover aircraft in such a short space. A shore runway may stretch for thousands of feet, but a carrier has only a compact landing area surrounded by antennas, parked aircraft, weapons crews, and the sea. The aircraft must catch an arresting wire, and the wire must absorb enormous energy without failing. Modern carrier recovery systems are built around cables stretched across the landing area. Engines below deck, hydraulic or digital controls, and crews who inspect the system between recoveries. The process starts before flight operations begin. Deck crews check the wires for wear, proper height, and tension. Below deck, arresting gear operators inspect engines, purchase cables, sheaves, valves, and control stations. When an aircraft lands, its tailhook drags across the deck and catches one of the wires. The wire pays out through machinery below, slowing the aircraft in a controlled run. A carrier-based Mk7 system can stop a 50,000-pound aircraft in less than 350 feet, showing how much force is handled beneath the flight deck. Installing and maintaining these systems is difficult work. During catapult and recovery work on a carrier such as USS George Washington, crews handle heavy components, route cables, align hardware, and test equipment before flight operations can resume. Cable testing checks whether the system can take load, return properly, and stay ready for repeated impacts. The danger is real. An E-2C Hawkeye near miss involving Screwtop's pilots became serious enough for pilots to receive the Armed Forces Air Medal, a reminder that carrier recovery leaves little room for delay or mechanical trouble. When a large aircraft approaches the deck, the landing signal officer, pilot, hook, cable, and arresting engine must all work together in seconds. If the hook misses the wire, the pilot adds power and launches back into the air for another attempt. If the wire catches properly, the aircraft stops hard, folds into deck traffic, and becomes part of the next cycle.
Right. Ramp.
That is why the C-2 landing is so impressive. The aircraft is bigger and heavier than most carrier-based jets, yet it must use the same unforgiving system. A safe recovery is not luck. It is engineering, repetition, inspections, pilot skill, and deck discipline turning a dangerous impact into routine naval aviation. Each stop proves the machinery and crew are still ready. Long before modern carrier delivery aircraft became familiar, the Navy and intelligence community tested an even stranger idea: landing the U-2 Dragon Lady on an aircraft carrier. The U-2 was built for high-altitude reconnaissance, not shipboard aviation. It has long glider-like wings, bicycle-style landing gear, and a design meant to climb far above ordinary traffic. In mid-1963, Project Whaletail examined whether the U-2 could operate from carriers, giving the United States a way to launch strategic reconnaissance missions from the sea. The concept was bold, because the U-2 is difficult to land, even on land. Its long wings create lift at low speed, and the pilot sits high above a narrow landing gear arrangement. On a carrier, the challenge becomes extreme. The ship moves, the deck is short, and the aircraft must descend without floating past the landing area. Modified U-2 aircraft received carrier equipment, such as an arresting hook and structural changes, while pilots trained to place the delicate aircraft onto a moving deck. The landing process demanded patience. The pilot approached slowly, keeping the wings level and judging height carefully. The aircraft crossed the stern, settled toward the deck, and the hook had to catch the wire before the U-2 floated away. Because of its wingspan and light landing feel, every correction mattered. A small error could push the aircraft high, low, or sideways. The test proved how far carrier aviation could be stretched when a mission demanded it. A normal U-2 launch on land also reveals why the aircraft is unique. Ground crews help attach temporary wing support wheels, known as pogos, before taxi. During takeoff, the long wings lift, the pogos drop away, and the aircraft climbs steadily toward extreme altitude. At operating height, the pilot works in a pressure suit, managing fuel, sensors, navigation, and oxygen, while flying near the edge of the aircraft's performance envelope. The landing on land is just as delicate. Chase cars often follow the aircraft, with another pilot calling height over the radio. The U-2 descends, balances on its bicycle gear, and finally settles as the wings drop towards support. Compared with the Greyhound's heavy carrier arrival, the U-2 story shows the opposite problem. An aircraft so light and efficient that convincing it to land can be the hardest part of the mission. Yet both aircraft demand calm hands, accurate timing, and absolute trust in procedure under intense pressure daily. Arresting systems are not only needed at sea. On land, military airfields use arresting gear during emergencies, rejected takeoffs, brake failures, hydraulic problems, or battle damage. Fighters may return with damaged landing gear, hot brakes, or limited runway remaining. In those moments, an arresting cable can give the pilot a final chance to stop safely before overrunning pavement. The BAK-12 system is a well-known land-based arresting system. Certification begins with inspection. Crews check the cable, tape, anchors, energy absorbers, hydraulic systems, and runway markings. They make sure the cable sits at the proper height so an aircraft tailhook can catch it. Technicians verify that the system can pay out smoothly, absorb the landing force, and reset for another use. During certification, a test aircraft or controlled engagement proves the system works under load. After the aircraft catches the cable, arresting units slow it. Crews inspect the cable path, and maintainers record measurements before clearing the runway. Mobile aircraft arresting systems take the idea further. At places such as Kunsan Air Base, portable arresting systems can be deployed where fixed equipment is not enough, or where operations need extra protection. Crews transport the system, position trailers or anchor assemblies, stretch the cable across the runway, connect controls, and test communication between operators and tower personnel. The goal is to create an emergency stopping system that can support aircraft under changing conditions. This land-based safety net connects directly to the carrier deck. Whether stopping a C-2 Greyhound at sea, recovering a U-2 during a rare carrier experiment, or catching a fighter on a runway, the principle is the same. The aircraft brings enormous energy, and the arresting system must take that energy in a controlled way. Pilots train for the sight picture. Ground and deck crews maintain the cables. Operators watch every engagement. Engineers design machinery strong enough to make violent stopping survivable. In the end, the skill of landing a massive aircraft on a carrier is not only about one pilot touching down. It is a complete system of aircraft design, arresting wires, deck crews, maintenance teams, and emergency recovery technology. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.